Hi, Algebra 2. We are heading into section 2 here with arithmetic sequences. Here we go. So like I said, we're going to be working with arithmetic sequences, and that's how it's pronounced, arithmetic. You can say arithmetic. They're spelled the same, but in this case, it's an adjective, arithmetic sequence. We are going to be seeing common differences in these sequences. Think of them like linear functions, but just using slightly different notation. So looking at this sequence right here, we want to know, could it be arithmetic or not? So we need to see, is there a common difference as we go from one number in the sequence to the next? And I see that every time here, we are going to be not subtracting, but adding 6 each time. So yes, it is arithmetic because that difference is the same. And so the next term, if I add 6, is going to be 20. As I look at the differences in this sequence, I notice that it's different every time. It's not a common difference. So this one is not arithmetic. Here we have the general rule for arithmetic sequences, and this is going to be an explicit formula, meaning to find any term in an arithmetic sequence. So this is it right here. You're going to be seeing this a lot. A sub 1 right here is the first term, and D over here is the common difference. And here I'm saying to compare this to our linear function of just the general y equals mx plus b. In y equals mx plus b, b was our first term or our initial value. We thought of it as our y-intercept. And the m was the common difference. That was our slope, meaning every time we went over 1, we went up 20, over 1, up 20, for example. And x was how many times were we doing that? In this case, how many times we're doing it is that term number right there. So they're very similar, just again using slightly different notation. In this example, we want to find the 12th term of this sequence right here. So first thing I need is the common difference. And I notice here that I am subtracting 6 each time, and there is a typo. This should be a -4 right there. And so now I'm looking back up to my general form here. A sub n equals a sub 1 is the first term, so that's going to be 20, plus n minus 1 goes in there as our general term number, and d is the common difference. That's going to be -6. I'm going to write it like that, so it's multiplying. So now I want to find the 12th term, so a sub 12 is going to equal 20 plus 12 minus 1 times -6. And as I worked through to solve this and just simplify, I found that my 12th term was -46. So far I figured out that my common difference is -2, and I filled in my general form with a sub n is going to equal my first term, -3, plus n minus 1 times -2. In this example, I'm going to show you two different ways that you could solve this. We're going to find the missing terms in the arithmetic sequence. The first way that I see this is that we went down 24 from 17 to -7 is going down 24 over the course of 1, 2, 3, 4 terms. So if I went down 24 over 4 terms, that means each time I went down 6. So my common difference is going to be -6. That's the D. So if I know my common difference is 6, I would be able to fill in my missing terms, just going down 6 each time, and then making sure that, yes, it lines up and matches, that it makes the sequence work. The other way is by using our general form for the arithmetic sequence, and I made a note for myself over here that my first term was 17, and my 5th term right here is -7. So now I'm going to fill in what I know. A sub n is really going to be any term. Well, I know a sub 5 is -7. So I'm going to put in -7 there, equals a sub 1 is 17 plus n. Now that's the term number from this term right here. So my term number for -7 was 5. I'm going to put in 5 minus 1 times d. I'm trying to figure out the common difference because we're pretending that we don't know it right now. And now I have an equation that I could just solve like any other equation. And when I solve that, I end up with D equaling -6. So I found my common difference to be -6, and I could then use that right over here to fill in the rest of my squares. Here we have two terms that they give us, and we want to find the fifth term of that sequence. So the first thing we need to know is our common difference. What are we adding every time in this sequence? And I'm noticing that I'm going from 85 to 157 over the course of 6 terms. Or in other words, I'm adding a total of 72 over the course of 6 terms. So adding 72 over 6 terms, that means that I have a common difference of 12, or adding 12 every time. Looking back at my general formula, I now know D, but I do not know the first term yet. So we can use maybe one of our terms here to figure out the first term. Here I've taken the general form and I've filled in some things that I know. I use this 8th term right here. A sub 8 is actually 85, equals a sub 1, I don't know what that is yet, plus 8, because this was the 8th term, which was 85, minus 1, times our common difference, which we already found was 12. So now I can solve this like a regular equation to find my first term. Okay, so I'm starting again with the general form. Now I know that D is 12. I know that I'm looking for the 5th term. And I know that my first term was 1. And again, I'm looking for what is the 5th term here. So I filled everything into my formula, and now I'm just going to simplify. And we'll see that the 5th term is going to be 49. The last thing we're going to do is how to find the sum of the first n terms of an arithmetic sequence. So in our example here, we want to find the sum of the first 16 terms for this sequence right here. And I can see that my common difference is going to be -5. So I start out by using, again, my general form because I need to find what the 16th term is. And so I'm going to know that a sub 16 is going to equal my first term, which was 12, plus n minus 1, so 16 minus 1, times my common difference of -5. My 16th term is going to be 63. Now I'm back up here to figure out how to find the sum. So add up all the first 16 terms of this sequence. So s sub 16 is going to equal, and I'm just using this general formula up here to fill in what I know. N is going to be how many terms there are, that's 16. A sub 1 is the first term, which is 12. A sub n is that 16th term, which was -63. And then I'm dividing all of that by 2. So I filled in everything in and I just simplify. So when I simplified all of that, I got the sum of the first 16 terms to be 408. All right, Algebra 2, nice job working through this. And if you have any questions, please make sure you're asking either myself or a classmate or anyone it takes to help get your questions answered. Nice job, guys.